Welcome to another episode of Wicked Problems, the podcast where we examine seemingly intractable problems that the world is facing. This week we're looking at climate and climate change in particular. The National Oceanic and Atmospheric Administration in the US called last year the hottest on record by far. During the year, we saw many climate-related catastrophes, from large-scale fires to unprecedented flooding. And yet for some, the science of climate change is controversial. Many claim that even climate scientists don't believe it can be attributed to anthropogenic actions, that is, man-made actions. To understand what climate scientists really believe, we thought it best to speak with one. So in this episode, I'm joined by Professor Herman Russchenberg. Professor Russchenberg leads the Climate Institute at the Technical University of Delft and is the scientific director of the National Ruisdael Observatory, both in the Netherlands, which is an apt choice given that roughly 1/3 of the Netherlands lies below sea level, the lowest point being 6.7 meters below, and so rising sea levels for them are an issue. In this episode, Professor Russchenberg and I discuss what businesses can do, the role of technology in mitigating some of the worst effects, why we're seeing the recent events that we're seeing, the role of pollution, the warming of the oceans, where we're headed, the inaction of politicians, the misuse of carbon credits, the need to change the way we operate and build our houses, our cities, and our conurbations, our urban conurbations. So quite a lot. Why this topic? Well, innovation drives business and is crucial if we're to mitigate the impacts of climate change. In other words, if we do things properly, if we innovate properly, we can not only save our planet, but we can make a profit too. Enjoy. Welcome, Professor Russchenberg. Have I got that?
Yes, that's fine. Yeah, that's my name.
Very nice to have you on this episode of Wicked Problems. Thank you for making the time to talk to us. I'm very excited about this. It is, of course, a very hot topic, if you'll pardon the pun. And, of course, I saw you give a talk on this subject in The Hague, Den Haag. And we are, of course, talking about climate change or global heating, global warming, whatever you want to call it. And it is a hot topic because it for some reason seems to be quite controversial with some people, but not really, I think, in the mainstream. And one of the questions that I see people, or no, it's not a question really, I see people say, there are climate scientists who don't think that global warming is happening, but I don't find that when I look into into what the papers say. So I don't know where they get that from, but maybe you could tell us a little bit about where we are, how perilous the situation is. And I think it'd be really interesting to understand, presumably we're not at the point where we all just shrug our shoulders and wait for the world to burn. There are things we can do, and maybe there are practical steps that we can take as individuals, but also as businesses, right? Because if we leave everything to the politicians, well, legislation takes a long time, even if they're on side. So maybe there's something that as businesses, the businesses can do to slow the progress of climate change and perhaps even to push it into reverse. I don't know.
Well, your first question is, where are we now, right? So what's the situation now?
Yeah.
Well, it's not good. So that's the happy start of this talk. Right now, the world is warming, and it's 1.2 degrees more or less that we are above the pre-industrial mean temperature globally. And already you can see the consequences of this, right? If you just look back on last summer with the extremes we had globally in India, south of Europe, Brazil, Canada, we saw all these extreme, and also the US, all these extreme heat episodes across the globe. And the consequences of this, the heat itself, but also the droughts that you get with this. We saw this strong warming of the oceans, and the seawater was much warmer than normal. There's this a contribution of El Nino, and there's a climate change contribution. It's it's complex, but we see these changes are happening across the globe. If you look at what might happen in the future, so what's still in us for the future. And then at the current rate of climate change and the current climate policies, we might be heading for 2 degrees or 2.5 degrees of warming. So we're not even halfway at the expected warming that we might see in later this century. And already we see these consequences that we have experienced, the extreme heats that we saw everywhere. So that means that if the global warming continues at current pace, and we continue with the current climate policies, this is going to be far worse in the future. But that's not good news. But it really means that if you want to avoid this type of climate change, we have to do much more in terms of reduction of greenhouse gases, but also adaptation to the consequences of climate change.
You said adaptation to the consequences. That sort of implies that we can't escape some of the consequences now, that we're at a point where we might do things to limit it, but we are going to have to do some adaptation. Is that correct?
Oh, yeah, of course. I mean, suppose we would stop with emission of CO2 today, then we're still dealing with this high concentration of CO2 in the atmosphere. Today, the concentration of CO2 in the atmosphere is far higher than it's ever been in the last 800,000 years. So it's enormous for what we already put in the atmosphere. So, and that leads to the current warming that we see. So the consequences of the warming that we see today will not go away, because we already have this type of this CO2 in the atmosphere. And so that is if we stop emitting today. Well, that's not going to happen. So we will pump more CO2 into the atmosphere. That means the consequences of climate change will only increase for the worse. So that means, we have to adapt. This adaptation, will occur at different levels. So, the cities, you have to change the cities because they're far more vulnerable to the heat than, for instance, the countryside. But the warming in there, so we have to change our housing. We have to change the organization of the cities, our mobility systems in the cities, just to deal with the climate change. But also the countryside is changing. I mean, if you look at the south of Europe, well, it's slowly drying out because it's much warmer, and the frequency of droughts in south of Europe also has increased. So we have to adapt there because it will affect agriculture over there. So adaptation is going to be important already, and we have to adapt to the consequences. And the longer we wait with a stronger climate policy to reduce the greenhouse gases, the more we have to adapt.
So what kind of steps do we take to adapt? What things do you talked about transport and infrastructure, housing. Does that mean we kind of need to make our housing more spread out, or what is that? Or do we just need the materials that we use, or do we need to make it more insulated, or what do we need to do?
That will depend on where you live, right? In here, so in Holland, it's we have a tendency of thinking of insulation, isolation measures, so to keep the heat in. But now we also have to think of how to keep our houses cool in the summertime. I mean, we never thought of this. So we only think about how can we keep the heat in, because we don't want to spend so much energy. But now in the summertime, we have to think reversely. So maybe change the housing, or we change the cities. So by having more water surfaces or more trees or green areas or parks in the city, it can bring more cooler air into the city. So it's on city planning level that you have to think differently. But also, on what you mentioned yourself, materials, what sort of materials do you use? How do you construct a house? So what options do you have there for building cooler houses? Different systems. Also, your transport, I think, should change. But you have to move away from all fossil energy-driven transport systems. You also might have to reconsider the mode of transport in the city. Right? So right now we have lots of private cars. Well, certainly, if you go to the US, it's only cars. You might have to go to a more public transport system with sharing cars or So to reduce the production of heat by these cars and reduce the emission of air pollution and greenhouse gases by these cars. So different ways of dealing with this in the city. But also when you think of adaptation, well, also I'm Dutch, so we always think of sea level rise. So, so you have to think of how to coastal protection. So what are you going to do there? If the sea level rises with 1 meter, 2 meters, 3 meters, what sort of actions are you going to take there? Right? And this is only in the western part of the world where we can afford this. But if you go to Asia or the poorer parts of the world, you have to think of different ways of adaptation, collaboration with nature and nature-based solutions. So it's a wide spectrum of adaptation that you have to think of.
Are we seeing sea level rising now? Is that something that we...
Yeah, it's happening already. Sea level rises on average with something like 3 to 4 millimeters a year. It doesn't sound like a very big number. It's like this. But it still is because it adds up. And the mean sea level rise doesn't mean that much. There's a lot of spatial variation of sea level rise. And some parts are affected more than other parts. But sea level rise is happening. So the last century, so it was over here 20 centimeters, 25 centimeters. It will be 1 meter by the end of the century. Then we're going to get more melting of the ice, expansion of the water, because if the water heats up, then it starts to expand. So that gives one contribution to sea level rise. The other contribution is, melting ice.
Yeah, so melted ice that's already in water doesn't have that much of an effect on the sea level rise, but it's the stuff that's on Greenland or Greenland or in the Antarctic.
Yeah, it's the land ice.
Yeah, and you talked about, and also the water itself being more expansive as it heats. But you also talked about the mean measurements not being that meaningful because of spatial variability. And that's, you earlier talked about 1.2 being the average raise in the temperature of the globe. But again, that presumably is an average and not that meaningful on a spatial level, because presumably it's different at the Arctic than it is, say, in Southern Europe. And that also has an impact.
Oh, yeah, definitely. I mean, if you look at the map of global warming, then you can see that the northern parts are closer to the Arctic. There's much more warming than if you go to the equator part, right? But this spatial variation is quite large, and there are many causes for this. For instance, here in Western Europe, the warming is much larger than the global mean. That's because part of the warming, the warming due to CO2, had always been masked by air pollution. So the air pollution, so you get dust particles in the atmosphere, and they reflect sunlight. And reflected sunlight doesn't heat the surface of the Earth anymore. Mm-hmm. So it compensates the warming. So it means that during the 60s and 70s in Europe, when we had a lot of air pollution here, the effect of the warming due to CO2 had been partly compensated by reflection by air pollution. This was called the global dimming in this period of the dimming effect of air pollution. Right now, since we have, for a large part, cleaned up the air, we have unveiled the warming of CO2, so we get more warming because of this. So now we see the bigger impact of CO2 of the warming itself, which is more than 2 degrees already in Europe. And in other parts of the world, and if you go to Asia, we still have a lot of air pollution, like masking the warming due to CO2. So this spatial variability of air pollution across the globe also leads to spatial variability of the temperature across the globe, and the global warming across the globe. And that's all these mechanisms that they play a role. And that's why the mean itself, the mean temperature itself, is useful in terms of communication, right? So you get a feeling for what's happening with the globe as a whole. But if you want to know what's happening in your own backyard, well, you have to be much more specific.
So there's a sort of double-edged sword there, isn't there? Because, like, if let's say you're in Asia, well, do you clean up the air because it's killing people because they're inhaling pollutants, or do you? But if you clean up the air, then are you exposing people to the dangers of climate change?
Yeah. And that's the mess we are in. There's no way we will say, well, let's pollute the air because of climate change, because people will get sick. So you want to have clean air for people to breathe in. And if you now go to cities like Delhi, for instance, well, it's last autumn it was a very bad period. There were even warnings: don't go out on the street because it's too dangerous to breathe. Well, that's not the situation you want. So you want to clean the air.
Yeah.
But you have to take into account what the consequences are for the warming. I mean, that will increase.
This is like a systems problem, isn't it? Because if you just treat the symptoms and not the underlying cause, whatever that might be, I mean, which is another question, I suppose, because on the one hand, the underlying cause you could say is the rise in CO2, but that's also an outcome of things that are happening within the system, right? So it's an outcome of steel production, of car production, of fossil fuel burning, of these things. So do things like renewable energies help to at least curtail the extent of the problem?
Definitely.
Right.
If you look at the sort of solar and wind energy production systems, they are far more sustainable than the fossil energy production systems. So in terms of CO2, also over the whole lifetime. So if you make a life cycle analysis of the production of wind turbines until the decommissioning, and still the CO2 production or emission due to wind turbines is far less than of fossil energy for the same amount of energy.
Same for things like photovoltaic cells in solar panels and so on.
Yeah, the same thing. So solar and wind are really they are a way out. So solar energy and wind energy, and of course it doesn't come for free. There is this issue of the materials you need for this, the critical raw materials that you need for this. But in terms of CO2, so for the climate perspective, yes, it's the way to go.
And I mean, he talks about pollution as well. We see a lot of pollution in the seas, and he talks about the heating of the sea. To what extent is that a complementary, a weird use of the term complementary, but a complementary problem to the climate problem? Because, there's a lot of dumping of sewage in the sea. So there's plastics, microplastics, fossil fuel derivatives. These things are turning our oceans more acidic than they used to be. Does that also have an impact, do you think, on if we could stop that, if we could pull away from that, would that help because the ocean's a very big part of the planet, right? So, and you've got the surface microlayer with all the stuff that goes on there, and you've got all the plankton and all and the fish that are dying and so on. If we can nurture our oceans back to health, does that help?
It will help, definitely. Because oceans, they absorb CO2 from the atmosphere. So it's a sink of CO2. So most of let's say, no, not most, it's something like 25% of the emissions of CO2 so that we put into the atmosphere today ends up in the ocean. It's a sink. So partly it reduces our emissions of CO2. And you can increase this impact because if you have more plankton, so let's say oceans which are more full of life, put it like this, then you absorb more CO2 from the atmosphere. But that helps. That would help. So, but then cleaning up the oceans. Because you have to be, in terms of climate, be more specific about what you want to remove from the ocean. And just saying cleaning the oceans, that in itself is not enough. You must be specific. So, right, so what sort of elements do you want to remove from the ocean for a climate impact? And that's quite complicated because the reason why the oceans are uptaking CO2 from the atmosphere is linked to the temperature of the ocean. So the cooler, the more it will uptake. And it will also need more plankton in the atmosphere, in the oceans, for uptake of CO2. But we can stimulate this by making the oceans healthier for these. Then it will work. That's interesting what happened last autumn in relation to climate change. We saw that certainly North Atlantic Ocean was much warmer than normal. Really much warmer than normal. There are several theories behind this. So why was it so much warmer? And one of them is that is due to cleaner air. So we have since 2020, there are stronger regulations in place for cargo ships over the ocean, and more filtering and removing of the air pollution they produce over the ocean. And this air pollution that the ships are putting into the atmosphere changes the cloud deck over the ocean. It makes the cleaner air makes the clouds less reflective. And that means that that's a kind of Faustian deal, if you want to call it like this. On the one hand, you want to clean the air by putting more environmental regulations on all these cargo ships. But as a side effect, the clouds over the ocean became less reflective. So more sunlight could reach the surface of the Earth and heat the ocean. And a warmer ocean of a large scale means, in the end, more climate change, more weather. Let's say not climate, that's for this longer term, but at least it has direct impact on weather patterns.
Which should then have an impact on climate across the...
Yeah, exactly. So if this is a long-term effect for the next 30 years or so, then you call this climate.
Right.
You see that also here. You see this interplay between air quality measures that you want to take for all sorts of health reasons, but also the climate impact it will have.
So we talked about oceans, we talked about cities and so on, but what about deforestation?
Deforestation has a significant role, really. It plays a large role in the emissions, because the larger deforestation, the more CO2 you allow into the atmosphere. So on the one hand, you remove a tree which will absorb CO2, and the tree that you just chopped will slowly release the CO2 stored in the wood itself back into the atmosphere. So it will increase the emissions. But if you look at the total numbers, then on average, something like 10% of the total CO2 emission into the atmosphere is due to land use changes, including deforestation, and 90% is due to fossil energy. So deforestation is really very important, and we should minimize this as much as we can. But we should not say, well, this is the main thing. The main thing is really burning of fossil energy.
It really is the main driver for...
That's the main driver.
And so if I was to be very simplistic, then the best thing we could do is just stop the burning of fossil fuels right away, and then work out how we stop the 30-year... I think you said there's like 30 years worth of, undealt with stuff in the atmosphere that that's just going to have an effect as it rumbles through.
Yeah.
And we need to work out how to have an effect on that. We're probably not going to get to the point where we can stop fossil fuels tomorrow.
Not tomorrow. No, tomorrow's weekend, so that's going to work. No.
Yes, today is Friday. So it's not going to be stopped on a Saturday, that's for sure. One of the things that I sort of wonder about, so the rise of CO2 in terms of percentage of atmospheric content is, I think it's 3.8 to about 4.2. Is that right? Mm-hmm. In terms of content, which is, if my maths is not too silly, just over 10% rise in CO2. So that's quite a shift in the amount of CO2. coming in. What's it displacing? Is it displacing, if you like, should we be worried about the amount of oxygen that there is in the atmosphere or anything like that?
Because if you look at the total amount of CO2 in the atmosphere, it's very, very small. It's 0.04%. So that's that's really nothing. And oxygen is more than 20%. So it's much more. So don't worry about this. There's plenty of oxygen in the atmosphere. The only reason, so 0.04 doesn't sound like a big number.
Well, that's the thing that I think people struggle with. Right?
Yeah. So people say something. Yeah, what can 0.04% do? It's nothing. So how can this be so important? And the main reason for this is that most of the gases in the atmosphere, so nitrogen, oxygen, they play no role with radiation. They're not affected by radiation, and they don't affect radiation. So the radiation balance of the atmosphere, so the incoming solar radiation, outgoing heat radiation, is mostly dominated by the trace gases, what we call the trace gases in the atmosphere. So the gases with a lower percentage. So
CO2, methane.
Yeah, water vapor, CO2, methane, ozone, they all occur in very small amounts. But these gases that occur in small amounts in the atmosphere, they are sensitive to radiation, to solar radiation, heat radiation. The gases which occur in large volumes, they're not sensitive. They are inert to radiation. So that's why you can forget about it. And then CO2 is an important one because it's a significant part of the radiative active gases in the atmosphere. And it has a very long lifetime. It stays there for a long time in the atmosphere, which is different from, for instance, for methane or water vapor. Methane has a lifetime of a couple of decades in the atmosphere. And water vapor is part of the natural cycle. So if you have too much, it will rain out again. So it's a much shorter life. So these small numbers, you have to always put the small number in perspective. And then, and even if it would be a small number, also including nitrogen and so on, then you can always say to people when they are concerned about the small numbers, also a small virus can kill you. The numbers themselves don't mean that much.
Yeah. The big numbers don't mean so much. The small numbers are much more meaningful.
Yes.
That's what I think the message is there. It does also raise the question, though, because we talked about earlier, what could we do to halt the progress? And maybe, we could just turn off the taps on fossil fuel. We could, move to more towards renewables like solar and wind power and so on. Is there a place for carbon sinks, do you think? So we have there's lots of elaborate plans, isn't there? Great big rods sticking up into the sky, vibrating and collecting carbon or whatever it is, planting trees. Is there a place for carbon sinks?
I'm afraid so. Yes, I'm afraid so. Yes. Why I'm saying like this, I'm afraid so, because if you look at the scenarios for reduction of CO2 in the future, and then you look at let's say scenario to stay below 1.5 degrees or stay below 2 degrees, you always need what we call negative emissions. You need technology to remove CO2 from the atmosphere, and you need those for what we call the hard to abate emissions. For instance, for the next couple of decades, it will remain difficult to fly with electrical planes. That's not going to happen. Also, hydrogen, planes or long-range transport with cargo ships, that's not going to happen with anytime soon with non-fossil energy sources. So we'll also have fossil energy in the system for these hard to abate emissions. That means if you want to have a net zero emission, you have to have technology to remove these CO2 emissions from the atmosphere. Otherwise, they will contribute to warming again. So I see this place that will be there. Why I'm saying I'm afraid so is that the option of such technologies of removing CO2 from the atmosphere is used in climate negotiations to delay the transition. Because now people will say, oh, that's certainly oil producing companies and nations, they now say, oh, we have this technology to remove CO2 from the atmosphere. We can continue burning oil and gas. And that's not what it should be. You should only do this technology for the things, for the CO2 that you really cannot do without. And not just for normal consumption of fossil energy sources.
Yeah, so it's not the case that we should be developing something that allows us to continue pumping CO2 into the atmosphere.
But that's happening now. So that's and that's wrong. That's really wrong. There's an example of it happened last summer in the US. There's a company called Carbon Engineering, which is specialized in these type of technologies to remove CO2 from the atmosphere, which has now been bought by US oil company Occidental Petroleum. And the motivation for this company to buy Carbon Engineering was to say, of course, if we have this technology, we can continue with our fossil energy and sell this for a much longer time. But for them, it's part of the business model to make a profit out of selling oil and gas for a much longer time. Because these companies, they have the problem that they already have lots of oil and gas reserves in their books, right? And that represents certain value. And if you now say, well, this will not be used because we cannot use it because otherwise we will cross the 1.5 degree line, they will lose the value of the reserves. That's in their interest to at least burn their reserves. So I think your show is called The Wicked Problem, right? Well, this is one.
It is a wicked problem because there's no, it's very hard to identify a constraint on the system that we could remove or something that we could change within the system that would cause this problem to not be a problem anymore. It would still be a problem, or it's potentially that it would create different problems elsewhere, unforeseen consequences maybe.
Yeah.
And it reminds me of what you're saying there of the trade in carbon credits that, you know, that they came out, didn't they, in the early 90s, I think it was, or mid 90s. They became at least that's when they came to prominence. And for a couple of decades at least, people thought you could solve, you know, well, I can emit lots of carbon if I just buy this bit of forest over here or lease it for a year even. But it doesn't work like that, right?
No. Well, yeah, of course, maybe it can work. The system, this ETS system can work. But of course, in the beginning, they gave away the rights for free. Right, so the start of the market was already a spoiled market because everybody got its assets for free in the market. And only now, of course, they're removing rights from the market every year, so it will become, by definition, more expensive for companies to buy and sell these rights, the emission rights. But because they got them for free to start with, it's still an easy business for them. Right, but in the end, it will work. I mean, if governments really put it back, well, you can only emit so much tons of CO2, or otherwise you'll be fined with this amount of money per kilogram or ton. In the end, it will work, but it's a very slow system.
This is a macroeconomic problem.
Yeah.
Your research or your work, what political will do you see within the various countries across the globe? Do you think it's going the right direction, or it's kind of people are a bit clueless, or it's going actively in the wrong direction? What would you say?
Depends on where you are in the globe. I mean, I think in Europe, with the Green Deal, those type of plans they have, it's heading in the right direction. I'm not saying it's moving, it's heading in the right direction. That's about as cautious as I can say this. But also the emissions, European emissions are going down. Right now, it's only 8% or so of the total. The global emissions are European emissions. So it's moving in the right direction, but not fast enough. US was moving in the right direction, but not fast enough. If you go in also China, it's moving in the right direction, but not fast enough. But then, if you look at the global South as a whole, they still need to develop, right? So they still have, and they have all the right to increase their standard of living to what we have in the West. That's a big challenge because they should develop themselves. They have the right to develop themselves, but there's no energy, at least fossil energy, left for this anymore because we use it up in the West. So we should really work hard to make this possible with innovation and whatever we can do for this, for them to grow in the development without using fossil energy. So it means that in negotiations, I would say, well, and I think politicians don't know this, but they have a hard time selling it, that in the West we should go much faster to create more time for the global South to develop. Well, this people know this, politicians know this, but they don't act accordingly. So now politicians can know this, but they're not acting accordingly. Because or what you see now with the populistic movement getting stronger in Europe, they deny the problem and they put all the problems on migration and those type of problems. Or in other parts of the world, they also deny the problem because the people don't want to see it. They have other things on their mind. I can understand if you're living in India, you don't care that much about climate change because you want to have clean drinking water first, right? The clean air first. So all this, climate change in that sense a bit abstract unless you see the consequences of this. Instead, you start to feel it. So it makes in the political systems, people know it, but they don't want to know it, or they don't want to see it. Because at that time, they might lose their vote, or they might lose the support of their voters.
So I suppose on the one hand, they might lose the support of their voters, but on the other hand, if they don't act, they may have no voters to have support from.
Yeah, but that's a longer term, right? That's a difference between the short term of every 4 years and the climate change, which is a slower event. You don't see it.
I guess that's right. In closing, I guess, is there hope? Is there things that people can do themselves? Are there things that, if anybody from a business is watching, what could they do?
There's plenty of hope. But all the hope has to start with the realization that you know how urgent the situation is. And you have to feel the urgency. And it's really urgent. And then there's still plenty of things that people can do on different levels. Now, if you look at individual level, you can do this. You can act well. Try to minimize your carbon footprint, if I put it like this. So think about when you buy stuff, do stuff, or travel, think about minimization of your impact on climate change, on the CO2 impact. But also at the system level, so the companies, they can do a lot by thinking about their impact all the time. So can you change your production schemes or your energy consumption in your company to minimize the CO2 impact? And I think governments can play a big role here by putting the constraints. And so these are the constraints for companies, but also individuals or for whatever. And giving companies the guidelines and the laws and regulations for doing this, to make sure that they create equal rules for everybody for this. That people should not be afraid of unfair competition in this case. The companies, the government should play a much stronger role than do right now in giving the regulations or dictating regulations for individuals and companies. And I think companies can play a big role here, not only because it's necessary, also because it's good for the business. They should do this.
Yeah, so on the one hand, I think if I summarize, we shouldn't rely on governments, but governments have a big place to play. So businesses can crack on without having to wait for governments. I think that's
of course.
But governments can incentivize through, I guess, regulation on the one hand. I would imagine also through incentives like funding incentives and so on.
Of course, they should. I mean, what you see at the individual level, what you see, for instance, that we talk about all sorts of measures for isolation of your house, right? It's people see this as costs. It costs money, right? I would say no. It's not. It doesn't cost you money. It's an investment in your future, and here the government can play a role. So simply put, right? So you do an investment today. So let's say you invest 5,000 euros in solar panels, so to mention something like this. Then, of course, this is an investment today. But for the next seven years or even longer, I have no electricity bill anymore. But in that sense, it's an investment. And once you have got your investment, you got your return on investment after 7 years, then after all this time, you got free energy. And suppose then at some age you retire, and if there's an example, then you have you have lower cost of living, right? Also during that for the rest of your life. If you think along those lines, so it's much more as an investment for the rest of your life than something you have to as a cost of today, and the government can really play a role here. Then it becomes a different story, and the government can play a role by making cheaper arrangements with subsidies or loan arrangements for them. That can work.
That's a very good point, and I think there's another point that I would just probably bring in as well. That if we get ourselves away from a reliance on fossil fuel, we also create less dependence on potentially, hostile nations.
Of course.
And I think that's probably also worthwhile doing. If people wanted to learn more, where might they go if they wanted to learn more after this? Where might be a good place for them to?
There's so many places that people can go to, depending on where you are. There are many websites, right, that people can look for. I think most universities in this domain also have portals that you can have a look. You can always send emails to anybody in the university on stuff. There's so many options there.
So you're at Technical University of Delft, who has a climate faculty, and I think most universities do. So people could go to there. I think I've got a link somewhere which I'll put under here if anybody's watching, which is a travel calculator. So you can calculate a way to get from A to B. And it tells you how much CO2 it would use, whether you're going by car or plane or whatever. And you can see, often if you go by train, for example, it's about 30%, I think, of the CO2 generated then compared to flying, for example. Professor Russchenberg, thank you very much for your time. We've really appreciated it. That's been fascinating. I actually think we could sit here for hours talking about this and still be uncovering more and more things that are of interest to people, but we don't have that time. But thank you for your time today.
My pleasure. Thank you.